We are going to take a little exploration journey into the rock pools, and we're going to explore all the phylum of animals, the groups of animals from the most basic sponges right through to the chordata, which includes complex creatures like you and me. So remember, these are all animals that we're going to see in the rock pools, all groups of animals, not plants. And the reef that we're going to explore, or the rock pool that we're going to explore, is in the Indian Ocean. It's at about 30 degrees south. This is it here. It's not especially large, and all of these animals we found in this small space. You can also see there's some human impact, lots of footprints on the beach, people that go into this rock pools, and ships out at sea. In spite of that, we're going to find all the groups of animals. If you go to your nearest rock pool, try to go at the low tide, or better yet, at the spring low tide, which is at full moon or new moon. And also protect your feet, so wear some reef shoes, but also don't let those reef shoes allow you to trample on some of the more delicate creatures on the rock pool. Also, try not to touch anything, and if you are going to touch things, make sure you really clean your hands thoroughly. No sunblock and other chemicals on your hands. So let's start off with the most basic animal in the animal kingdom, the Periphera sponges. This happens to be a chili pepper sponge, but they do come in all kinds of shapes and sizes. And they're really, really basic. They're not really made of all that much silica, calcium, spongin. And there's not too much complexity inside of them, but they do have a lot of channels and pores. And inside all of these channels are lined with a little flagellum, which is like a flicking tail. And so there's specific channels where the water gets sucked in by these flagellum and then pushed out of other channels. And they can actually process through them 1,000 liters per day of sponge tissue. And what they're doing is they're removing 90% of bacteria and absorbing 90% of the carbon, the dissolved carbon in the water. So they're sequestering carbon and cleaning the water and doing this amazing job for one of the most simple animals in the whole animal kingdom. They're doing really quite an amazing thing out there on the rock pools and reefs. Moving on to the next group, the Nedaria. You'll know the Nedaria as being the groups that the corals belong to, and the beloved anemones, which is what we're looking at here. Also the bluebottles, which is Portuguese man of war, and the jellyfish. And you can just see or imagine these anemones are like a jellyfish that came and plonked themselves on their head and started waving their tentacles in the air. And all of them have that stage of their life cycle where they're floating around like jellyfish, and then the anemones and the corals have the stage of the life cycle where they come and plonk themselves down on the reef, or they're in the rock pools, and they're waving their tentacles in the air to catch food. Also, closely related to the anemones and coral reef and corals are the zoanthids. So here we see a zoanthid colony really spread out over the reef. Of course, this is usually submerged underwater. It's because it's spring low tide. And I've touched it here, although you shouldn't normally touch it. I've touched it here just to show you how soft it is, because in the guidebooks you never really get a good idea of how soft or hard they are. So they're really quite soft, and you can see they're just like a closed up tiny little anemone. And this is like a very large version of what a coral would look like, and a very small version of what an anemone would look like. Again, when the tide was high and the water was up and they were submerged, you'd have all the tentacles out and catching food, but the tide is low, and so they're all closed up to prevent themselves from desiccating. Now let's move on to the phyla of worms. Okay, so there's loads of phyla of worms. There's your flatworms and your segmented worms, and these here are polychaete worms. Polychaete means lots of hair, and so all these worms have lots of legs with lots of hairy bristles on those legs. And these blue coral worms are building sometimes inches of these tubes that they deposit around them, these hard tubes. So they build a substantial amount of the reef structure and the rock pool structure, sometimes inches thick. And then during the low tide, they've got this cap-like plug that they've closed, and they've gone and hidden inside their tube. But when the tide is high, they come out again with these little antenna tentacles to catch food. Now let's move on to the arthropods. Arthropods you'll be most familiar with as the insects of the land, and the insects of the sea, if you will be all of these guys, connected to the barnacles, the shrimps, the lobsters, the crabs, and the amphipods. These are, of course, barnacles, and we're looking at volcano barnacles and tooth barnacles in this picture. The barnacles have a stage of life where they're just free swimming around, and then at a certain stage they come and plonk themselves down here on the reef, and they attach to the reef with their antenna or their heads. They grow this shell around them, they deposit the shell around them, and what's going to come out as the antenna in the water to catch food is actually more like their legs. So they're kind of plonked on their head with their legs waving around in the air like they just don't care. They also have, fun fact, one of the largest penis to body size ratios in the animal kingdom, and that's so that you can see with these distances between them, they can send that organ out and fertilize barnacles around them. So staying with the arthropod crustaceans, we've got the well-known crabs on the left in this little rock pool. You can see scuttling around are the hermit crabs, and as they grow bigger and bigger and bigger, they're let going one shell and moving into another shell. And it's shells of an entirely different phylum. The next phylum along the mollusks is what they're living in. So abandoned shells of mollusks, and they're growing up and then moving from one shell into another. So that's the loved hermit crabs. And on the right, the more familiar crabs that most people know, various reef crabs, hundreds of species. All over the world, wherever you are, you'll be able to find some very interesting crabs. We're getting quite complex, as you can see. We're talking about eyes, fancy shells, and exoskeletons, and internal organs getting increasingly complicated as well. Now we move on to the mollusks. This is all the shells, the snail-type shells that you'd be familiar with, that people pick up and enjoy picking up along the beach. They start with the chitons. The chitons are really quite simple, just 8 plates, and then this foot that really attaches them quite hard to the reef. But they are a little bit more complicated than what you would think. There is a head end and a tail end as well. And after the chitons, we move on to the majority of the shell snails that you would be familiar with. And I'm looking now at the limpets. So on the left, we have a normal limpet versus a keyhole limpet with a tiny little hole on the top, and out comes from that hole a siphon. In the middle here, we've got your classic type of limpet. You don't often have the patience to sit around and see them moving around, but if you were to do a time lapse, you'd see they actually move an incredible amount around over the reef. You often will just see them fast and quite planted hard to the rock. They have much more complexity than you would think. There's muscles in there that it's attaching them hard to the rock. They've got an eye, they've got a head to tail sort of, end tentacles, little papilla that come out around the edge of that foot. And they scurry around with this ribbon-like tongue, feeding algae off the rock. And some species, like the pear limpet on the top right corner, actually feed on certain algae and leave other algae ungrazed, and thereby they're actually farming the reef and changing the whole algae structure of what's growing on the rock pool. And you can imagine with thousands of these limpets combined how they can actually make quite a big difference on a rock pool or reef. You sometimes find piles of limpets up a cliff or up a hill, and that is because they are predated on by seabirds, including gulls, and they'll take those limpets and drag them on up the hill. So very cool and interesting little creatures that you maybe take for granted when you see them under your feet. And you'll know how strong their muscle is. You can't really remove a limpet yourself from the rock. On the bottom right of the picture is a false limpet, and they're actually breathing air using a modified lung in their mantle, as opposed to everything else which has been using gills so far. Now we're going to find something that was quite a coup. I found some sea hares here, and instead of being protected by a hard shell, these are protected by their amazing camouflage. And if they weren't moving, I'm sure I wouldn't have spotted them at all. But they're moving around because they're actually in a mating chain. And they can be in a mating chain of a dozen sea hares, head to tail, and they're all fertilizing the one in front of them whilst being fertilized by the one behind them. As well as this incredible camouflage, when they are in the water, if they were threatened by predators, they could also emit like a purple smoke screen in order to confuse the predator, a bit like, squid to do. So that was quite a cool discovery on the reef. The next thing we're going to look at is the mollusk bivalves. Bivalves meaning two valves, and you always think of the mussels and the scallops as being two equal shells, but they also include the oysters, which have two shells but unequal shells. So everything with two shells generally falls into the bivalve family. And it would be a shame that we didn't include the cephalopods, which is the squid, the octopus, the cuttlefish, the very iconic, charismatic creatures of the cephalopods. Cephalopod literally means head-footed. So they have their tentacles coming out of their head, as you know, with the octopus and the squid. And this is the internal skeleton of a cuttlefish, which is rather like a fat-looking squid, and they are related to the octopus. And they're generally going to be swimming around the cuttlefish out over the rock pool and reef when the tide is higher. They'll be predated, and then the shell will float around for a little while and eventually come ashore. And you can actually see on the shell how long it's been floating around for, because it's picked up a few little bite marks from various creatures that were trying to nibble on it, as well as some stalked barnacles just in that back corner there growing slowly. So you can kind of gauge how long it's been floating for by the amount of growth accumulating on it. Moving on to one of the last phylum of animals on the rock pool is the econoderms. They include the sea stars that are all kinds of colors and shapes and sizes, brittle stars, etc., the urchins, which we all try to avoid standing on, and this cryptic sea cucumber. If you didn't know what you were looking for, it would be very easy to miss seeing this sea cucumber there in the water. And you'll probably recognize them looking a little bit more like this usually when they don't have all the sand and algae covered on them. So these all have that pentamic symmetry related to the sea stars and the urchins. These are the sea cucumbers. Kind of a delicacy nowadays. Now let's move on to the chordata. Apart from including you and me, all the other mammals, the birds, the reptiles, the amphibians, the bony fish, the sharks, and the normal fish, they also include some creatures on the reef that would surprise you. They all have a post-anal tail, a notochord, and a nerve cord, like us. And I'm going to show you the sea squirts, sometimes called redbait, and they're all tunicates. There's dozens of types of tunicates and ascidians. There's the little squirt that gives it its name. And this has that notochord and post-anal tail that I mentioned in the larval stage. So this is the first rudimentary vertebra before we actually get to the vertebrates. Quite amazing to think this unassuming little animal is more closely related to us than everything else that we've looked at on the rock pool so far. So that brings us to the end, from the most simple animal, the sponge, right through to the chordata with the sea squirts and ascidians. Hope you enjoyed that, and we'll do another one soon.